What if our ancestors understood reality not through equations, but through observation? Not microscopes, not particle accelerators, but patience, repetition, pattern recognition. Today, modern physics tells us something deeply unsettling. At the smallest measurable level, reality is not solid. Matter behaves more like a probability than a thing. Particles flicker in and out of measurable states. They act like waves until observed, and observation itself changes outcomes. This discovery shocked modern science, but here's the question that makes people uncomfortable. Why do descriptions of reality from ancient civilizations sound strangely familiar? This video is not claiming ancient people practiced modern quantum physics. They did not have calculus. They did not have lab instruments. But they did have something we often underestimate: long-term, disciplined observation across generations.
Once you admit intelligence didn't begin in universities, you have to rethink who gets credit for knowledge.
Many ancient systems developed accurate models of natural phenomena through repeated observation, even without formal mathematics.
For centuries, Western science assumed reality was solid, fixed, and objective. Quantum physics shattered that assumption. At the quantum level, particles don't behave like tiny objects. They exist as probability waves. They don't have definite positions until measured. Now, listen to how ancient cultures described reality. In ancient Indian philosophy, the world was described as Maya, not meaning fake, but meaning unstable, shifting, perception-dependent. In many African cosmologies, matter was not inert. Everything carried force, motion, and interaction. In ancient Greece, Heraclitus argued that reality never stops changing. You cannot step into the same river twice. This wasn't mysticism. It was observation.
Different continents, no communication, same conclusion. That's not coincidence. That's pattern recognition.
Modern quantum field theory now describes reality as fields in constant fluctuation, with particles emerging temporarily rather than existing permanently.
Across civilizations, creation begins the same way, with vibration. In ancient Egypt, creation begins with speech. In Hindu traditions, the universe begins with Om, a vibrational frequency. In African societies, drums were not entertainment. They were communication technology. Modern physics now confirms something extraordinary. Everything vibrates. Atoms vibrate. Cells vibrate. Even empty space vibrates. In laboratories today, scientists use cymatics to show how sound frequencies shape matter into visible geometric forms. String theory proposes that the smallest building blocks of reality are vibrating strings. Different frequencies produce different particles. That doesn't mean ancient people knew string theory. It means they observed vibration as fundamental long before we could measure it.
They didn't have formulas. They had ears, eyes, and memory.
Frequency directly determines energy states. Sound and vibration measurably affect physical and biological systems.
One of the most uncomfortable discoveries in quantum physics is the observer effect. Particles behave differently when measured. This does not mean the human mind magically controls reality, but it does mean measurement matters. Ancient societies trained attention deliberately. Meditation, ritual focus, collective observation. They believed awareness changed experience. Modern science resisted that idea until experiments forced it back into the conversation.
Basically, reality behaves differently when you look closely.
While consciousness interpretations vary, observation measurably alters quantum outcomes. This remains an active area of study.
So why was this knowledge dismissed? Because it wasn't written in equations. It wasn't industrialized. It lived in bodies, rituals, and memory. Colonial systems separated science from meaning, measurement from wisdom. Now, modern physics is circling back, not to spirituality, but to humility, to the idea that observation doesn't require domination to be valid.
Turns out, our ancestors weren't behind, they were early.
Scientific advancement often involves rediscovering principles previously observed through other frameworks.
The universe hasn't changed. Only our language for describing it has.